Today we are going to talk about methods. So a method is a block of code grouped together. So I say it's a block of code grouped together to perform a particular operation. Yeah, no worries. I just typed it fast. Doesn't mean you have to be as fast. We've already used some methods a little bit, but we're going to talk about them formally today. You call a method using the dot operator and an object name. Example. So yeah, I'm saying I got a 5.0. It's not really true. I think I was more of a 3.87 college student. I'll be honest with you. I was the B+ king. It's not a bad place to be. So, a method's a block of code. Does a particular thing. You call a method using the dot operator and the object name. So here I'm showing you I made an object called Hayes. That's a student object. You know, this is a little bit, like last week we were talking about book objects. Just imagine I had a class called student, and I created this student. And then there's a method. This is the method, set GPA. This apparently takes a double value, and you might imagine that it sets the GPA for that object. So if you had a student, you might want to be able to say this student's GPA is, and then a number. So that's an example of a method. It's interesting. You can use a method if you know what it's supposed to do. You can use it even if you don't know how it does it. Like, we don't have to see the code in the method. We're going to use methods that Java provides that we don't have any idea how the things are done. This is called treating something like a black box. Have you ever heard that term before? Black box versus white box? A black box is, imagine a little box that's like a function machine. Something comes in, something comes out, and you don't really know how it happens, but you know if you put something in, you're going to get this other thing out. That's a black box. It means you can't see inside of it. It doesn't mean you can't use it. And then a white box is you can see, like you can see the code inside, and then you can still use it. But anyway, we don't have to know what's going on in methods. We don't have to know how they do things, as long as we know what they're doing. So methods are identified by their signatures, and the signature of a method is their name, their return type, and their parameters. So this word called return type, that's something new for you today, and I'll be explaining it. Jumped a little too high. So here's two examples. Public void set GPA double G and so the return type, everyone, is this thing here that says void. I'll underline the return type, and that's the other return type. So I'm not showing you what's inside these methods. I'm just showing you their declaration line. We would know their signature from this. Public void set GPA. That's like the one I just used up here. Set GPA, and you send a double over. And then public double get GPA. On that one, you don't have to send it anything because you're just asking for information. And you know what you're going to get back because it says double here. That's the return type. The underlined parts are the return types. And this is worth saying here. Constructors don't have a return type. That's one way you know they're a constructor. So you may or may not remember, but on Friday we had public book with some parameters, public book with different parameters, public book with a third set of parameters. So those are constructors because they don't say public void book or public int book. But when you have methods, you know it's just a regular method when it's got a return type. And the return types we could have right now are void or a double or an int, like something could send you back an integer, or it could send you back a string. So capital S string is another type of variable. We're going to be working with strings more in just a couple days. Yeah? Void sends back nothing. So a void method, you'd say, why would we call a void method? A void method either makes a change to an object that we don't need to get something back, or it prints something. So often you'll have a void method that prints something. Like it doesn't send anything back, but something will get printed on the console so you know that something happened. That's a great question. It was, what happens if it's void? Does it do nothing? It could, set GPA, sets the GPA, and doesn't send anything back. Like it doesn't need to send the GPA back because you already knew the GPA. You sent it over. So, yeah, I like that question. Yeah, good. Then we're on track. I'm trying to not skip things by accident like I did last time. So, want me to go up a tiny bit? So this is a highly non-technical description, but I think you'll understand. When you call a method, Java interrupts the code. So you're walking through some code in a file, and then you call this method. Java goes and does that method until it gets sent back, and then it comes back, and then it just keeps going right where it left off. So, like if you're in one program and you call that set GPA call, the current program, the one calling that set GPA call, it stops. Java doesn't keep going until you come back from the method. So you go over, do whatever the method's doing, and then you come back. So you'll see it. It's not a big, complicated thing. But it's helpful to know. It's not like it's going to keep going and then now it's running two things at the same time. It does the method, comes back, and then keeps going. So the next point, void methods don't have return values. Nothing gets sent back. So you can't do an expression, you can't use a void method in an expression like this, like system.out.println hays.setGPA 3.78, because Java will say there's nothing to print. Like that, it knows that's a void method. Print calls need something in there, or just nothing. but you can't put something in there that will print nothing. So also another bad call would be int x equals Hayes dot set GPA. And the problem isn't, maybe I'll say double, it's not that GPAs can't be a double, it's that Hayes dot set GPA, the set GPA method, as I've defined it, is void. So it doesn't give Java anything to put into that other variable. So anyway, so a minor point, but you'll see. I mean, if you want to set the GPA, just have a line of code that sets the GPA. But it's not inside of a print command. And there's these things called static methods that we'll be using later, but I wanted to mention them. Some classes are defined as static, and for these, you don't have to instantiate an object to call their methods. So I'm going to show you an example. Math.abs. You might imagine this returns the absolute value of a number, and it does. You can make that call. You could say int g equals math abs 5. That's a perfectly good call. You don't have to say math m equals new math and then int g equals m dot abs negative 5. See how that we're doing it differently? If you're doing stuff to like a student object, you have to create the student object and then use methods on it. And I'm just mentioning as a heads up, there are these things called static objects, static methods, or methods on static objects. And the one we're going to end up using the most is probably this math one. And in fact, we may get to it today, depending on our timing. So you don't, it's not even that you don't have to say. You can't say math m equals new math. You can't create a math. What is a math anyway? So when we want to use math functions, they have trig functions, logarithm functions, square root, absolute value, exponents, all that. You just can call it. You don't have to. That's because math is defined as a static class. Okay, so then I wrote a little class called student, and I want to show you some commands with it, and then I'm asking you to do some things with it for a day 9 task. We also have a little half sheet I want you to work on. But I'm going to pop over to the development environment. So we have, I made a student class. Let's see. I mean, we're going to be right here. Where should I be here? I'll be here. You don't have to write this all down. I'm just going to show you an example. Student Hayes equals new student. And then I'm going to say Bob so it fits. Hayes and let's make sure that compiles. Can't find symbol. Capital S student. It's right here. Public class student. Oh, well, no. Thanks for asking. Yeah, that could be that, but I don't think so. I'll close that, and we'll open up my day 9 again. Oh yeah, it was in the wrong folder. That's all. Yeah. Remember, things have to be in the same folder. A lot of you ran into this problem Friday, and I thought, oh, I'll use my notes file, but I can't because it's not in the same folder. So, all right, so I created a student, Bob Hayes, GPA. I'm going to print it. We'll run it. Helps when you add a semicolon at the end of the line. All right, so here's Bob Hayes, GPA 3.78, average 0. So I'm going to show you. We're going to run Hayes.setGPA. I'm going to go to 4.1, and then I'm going to print. And cool. So you could see the first print of Bob Hayes is the original GPA, and then we changed the GPA, we printed it again. We'll go here. And now, I have a method over here. I have 3 methods. It's overloaded. We have overloaded methods. GPA is not overloaded. Set GPA gets a double, sets the variable to that. But I have 3 set average methods. One takes 2 integers, one takes 3 integers, and one takes 4 integers. And each one is calculating the appropriate average. You know, the first one adds the 2 numbers, divides by 2, the second one by 3. And there's other ways, smarter ways to do this, but I wanted to have overloaded methods. So let's go back here. So it's in our notes. When you have methods with the same name but different signatures, it's called overloading. And overloading in some, like if you're feeling overloaded, that's got a negative connotation, but in Java this isn't negative at all. Just means there's more than one method has the same name, and they accept different parameters, and that's okay. We just have to know how it works. Java chooses the right one to run by looking at the information sent to it, the parameters. So then, bless you, back to the code. I'll show you again. I've got these 3 methods. They're all called set average. And the idea is, like as a teacher, I might say, I want these 2 tests to go in and set their grade based on these tests. Or, hey, I actually have 3 tests, or I have 4 tests. So back to my runner. We can call this a runner. This is a file that's just creating student objects just for practice. I'm going to say Hayes.setAverage, and I'm going to send over 4 and 5. Those are the, why don't we do test numbers, 94 and 97. Let's do that. And now let's system.out.println Hayes. Then, so we'll get one more. We have 3 printouts now. Here's the original Hayes. Then there's after I set the GPA to 4.1. And then this is after I sent over 2 tests. And I believe the average of 94 and 97 would be 95.5. It's kind of halfway in between. And let's... we're going to call the one that does 3 test scores, and we're going to call the one that does 4 test scores. And I'm going to just run them all so you can see. So this is using different methods. I've got set average used 3 different ways, and you can't always do that. We can do that here because we know that over here it's defined 3 different ways. There's set average with just 2 things, set average with 3 things, set average with 4 things. And this is, these are all void methods. So there's nothing, go ahead, nothing getting sent back. It's just setting the average to that thing. That's it.